Welcome back to Java Space. So in this video, I'm going to show you how to use the correct way of solving this problem that I explained in the previous video. And obviously in the Spring context, or even maybe in Java EE or other frameworks, when you talk about transactions, then you also want to talk about AOP, which is aspect-oriented programming. So with this issue, we saw that there is parts of code that repeats. Like if we say in the traditional approach, you will get a connection, begin a transaction, execute a query, then commit, then rollback. And you repeat that for all these method calls. You end up having code duplication. And with aspect-oriented programming, we want to have what we call separation of concern. We want to take that part of code that is repeating itself across your application and put it in its own place and in a separate location, and then just inject it where it's required. So a transaction is a cross-cutting concern. So it is that part of code that is replicated throughout your application, and you don't want that. You want to modularize it such that it can stay in one place and then be injected or used where it's needed. But before that, you always have to identify the transaction demarcation. So what does a transaction demarcation does? So a transaction demarcation will wrap a sequence of actions, such as a request, a method call, or a section of code within a particular method, which it then gets created. As to how it gets created, I have explained that in my series on AOP. So the demarcation will be the one responsible to initialize a transactional behavior before the demarcated area begins. And then it will also be responsible for ending that transaction when the demarcated area ends. So now, because we have all this repeating code, we have to move it and put it outside that particular demarcated area. So you notice that we talked about demarcated area, that you initialize a transaction before demarcated area begins, and you also end it. As a developer, I'm not really interested in how that management is configured or how that management is implemented. I'm only interested in my business logic. That's it. And all other nitty-gritties or the implementation details should be hidden away from me and should be left to a vendor to be the one to cater for that. As a developer, I just want to execute methods that can be executed as a unit, and the framework should be responsible for doing the management for me. Then you will see as we continue with the series how Spring hides the implementation details from us. So with this transactionality approach, obviously we have what we call connection pool, where when you need a connection, you don't make a call to a database management system. You pull that connection from a pool, a data source, which has been created well in advance for you. So now in this transaction, we see that all methods use one transaction, as opposed to the previous traditional approach where each method runs in its own transaction. And in this approach, if one method fails, all method fails. If one query fails, all queries are rollback. So by when I say all fail, it means that the previous ones that failed, they are rollback. So it means that the other methods that were successful, because one failed, then they are all rollback. And the importance of that, as I've mentioned in the previous video, is to leave our database in a consistent state. So now we see this is efficient, and we are reducing the overhead of acquiring and releasing connection for each method call. And now we are treating the whole transfer of money from one account to another as a unit of work. So you might be wondering how beginning of a transaction and ending look like. I'm just going to show you just the code here. So we see here what we are doing. We have entity manager factory, which we get from persistence contact, persistent unit. Then we have, so the entity manager factory, we get it from the persistent unit. Then we have the entity manager, which you get from the persistent context. Then we see here what we are doing is we say entity manager.get transaction.begin. Then we do whatever we want to do. Then we commit. If there was an exception, we roll back. So if we are doing all this for each method call, this is obviously not optimum. Why can't we put everything in here, which is what we want to do? And I already explained the transaction demarcation and everything that you obviously you need to know. So this is how a transaction will typically look like. But now, since we are saying transaction is a cross-cutting concern, we don't want to be doing all this for each time we want to modify a database. We just want to execute a business logic, and a framework should then begin a transaction and commit for us and roll back depending on the results of the execution.